All right, so I'm ready to look at 4 more quick examples, and all of them are discontinuous or have a discontinuity at x equals 0. Every single one of them has that same problem. So the question is, how are they different? So each one of these is going to be some form of discontinuity, and that's my goal, is to determine what kind of discontinuity. And also, the other important thing, each one of these examples is designed to catch a misconception. They're all designed to be difficult enough for people to be confused so that we can talk about how they're right. We can talk about the right answer. So here I go. I'm going to start off with this first one, this one over here on the left. We want to figure out what kind of discontinuity it is at x equals 0. So here's what I'm going to do. I'm going to look at the left side limit and the right side limit and see what happens. So if I look at the left side limit, the limit as x approaches 0 from the left of this function, it goes toward positive infinity. I can stop right there and say, I already know what the answer is. I want you guys to pause and think. What kind of discontinuity has a limit at infinity? All right. Now I'm going to go ahead and do the other side. The limit as x approaches 0 from the right is also infinity. Now, I said in the last video, that it doesn't matter if the left side does it or if the right side does it, if it goes to positive infinity or negative infinity. If it goes to infinity, doesn't matter whether it's positive or negative, then it's a infinite discontinuity. Okay? Here's the thing. This is where people are going to get confused. They're going to say, but hey, Mr. Harold, at 0, I have the value of 1. Doesn't matter. That does not matter one bit. What matters is the limits. The limit goes to positive infinity or the limit goes to negative infinity. It's an infinite limit. All right. Now that I've said that one, I'm ready to move on to number 2. Number 2. This one right here. I'm going to, again, try to figure out what kind of discontinuity it is. Now, if you notice, this is a piecewise function. On the left side, it's a straight line. However, on the right side, we're going up. Now, here's the thing. A lot of people, again, they look at me and say, hey, Mr. Harold, that's a closed dot. So I know at 0, the value is 4. Perfect. You figured that out. Wonderful. But I don't care. Here's the thing. I want to know about what kind of discontinuity it is. That's what I care about. So let me, again, look at the limits from the left and from the right. So the limit as x approaches 0 from the left, hopefully you guys figured out looking at the graph, it's going toward that closed dot at 4. However, if I look at the right side, the limit as x approaches 0 from the right, it's going up, all the way to positive infinity. Now here's the thing. I'm going to say it again. What kind of discontinuity involves infinity? Pause it and think about it. All right, so there's only one kind of discontinuity that involves infinity, and that's an infinite discontinuity. So that's what matters. But again, they say, hey, Mr. Harold, it's defined there. It works on the left side. It's a number from the left side. Does not matter. One of the sides is infinity. Doesn't matter if it's positive infinity or negative infinity, but it's infinity. It's an infinite discontinuity. All right, ready to look at the third one now. All right, on this third one, here we go. Notice I have a closed dot here at 0, 0. So I know what the value at 0 is. And I know that there's an open dot here at 2. So let's look at this. Again, approach it from the left and from the right. The limit as x approaches 0 from the left. Well, if I follow it from the left, it's going to go up and then curve back down and go toward the open dot at 2. Let's do it on the other side. The limit as x approaches 0 from the right. All right, it goes down, curves back up, and goes toward the open dot at 2. So here's the thing. My limit as x approaches 0 from both sides, the double-sided limit is 2. However, my point at x equals 0 is 0. So in this case, we have a double-sided limit that exists. That's an actual number, but the value is different. Think about it for a second. We talked about this in the last couple of videos. This is called a removable discontinuity. How? Because I can fix it. There's a hole right here. Even if there's another point somewhere else, doesn't matter. There's a hole right here. H-O-L-E. Hole. Once I figure out that there's a hole there, that means I know it's a removable discontinuity. Again, it doesn't matter if there is another closed dot somewhere else. It's a hole, so it's a removable discontinuity. Again, I can fix it. All I got to do is fill in the hole. Last one, last example. So here I go. I've got this one right here. Now notice, on the left side, it's a parabola. On the right side, it's another parabola. They're both open dots, and I have a closed dot here at 2. So here I go. I'm going to look at it. You ready? Look at it from the left and look at it from the right. The limit as x approaches 0 from the left. If I follow it from the left, it's going toward this open dot down here on the bottom, which is at 0, right here, this open dot. If I look at it from the right, the limit as x approaches 0 from the right. All right, I'm going up, 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 and I'm heading toward this open dot, which is at 4. Notice, both of these are numbers. Okay, we've got 0 on the left, 4 on the right. Here's the other thing. People always get confused. Mr. Harold, but there's a closed dot at 2. Doesn't matter. What matters is the left side limit, the right side limit are both numbers, but they're different numbers. What kind of discontinuity has limits on both sides that are numbers, but are different? Hopefully you figured it out. It is a jump discontinuity. But Mr. Harold, it's jumping from an open dot to a closed dot to another open dot. Okay, it's still jumping. Again, open doesn't matter. If the limits go to different numbers, left side and right side, it's a jump discontinuity. Hopefully that clears up any misconceptions you guys had on the different types of discontinuities. Again, the oscillating one is the easy one. Make sure you pay attention for. These are the trickier ones. Make sure you watch out for them. Hopefully y'all have a great day.